Hello everyone, my name is Arshavir and here I'm going to solve a truss problem. As you can see here we have a very simple one and there are boundary conditions here and here. There are also geometrical and mechanical features such as cross section, and there is also a concentrated force which is applied to the truss at this point. And our purpose is solving this problem in Abaqus and perform an analysis, and you are expected to be familiar with basic concepts of finite element methods. And if you don't know nothing about Abaqus, I suppose this video can help you and it could offer very good insights. Here we have some steps, and the first one, you must create a part. I enter a name, and as you want to perform a 2D simulation, I choose 2D planar. Obviously we expect that our truss will experience some deformation as a result of applying concentrated force, and I choose wire as base feature. Here I can create my wire. You can create any sketch. You have some useful tools here. You can, for example, create some points very easily, and also you can enter the coordinate of your points here, and then I create the lines. Here I have a very simple truss. There are some other tools here and we're going to work with them in future sessions. The next step, you must you must click on done here. It is necessary. When I click on done, yeah, now we are done in this part. Then we can define the properties. From here you can see many options. You can define mechanical, thermal, and other properties. Here I'm going to define the I modulus property, and then Poisson ratio. Okay, and then you must define your cross section. From here, from beam you can find truss, and then if you continue you can define cross section area. For material number 1, and then I'm going to apply the cross section and material. I choose all elements, and yeah, we are done here. In the next step, we can create an assembly from all your instances. As you can see here, all your parts can appear here. I only have one part whose name is truss. I prefer to choose independent and OK. And there are some other tools here. You can create linear and circular pattern, and if you have more instances, you can uh, create a very good assembly using these options here. And here, the next step, you must consider your procedure type. It depends on your problem, and obviously our problem is a static one, so I choose static general, and in incrementation I choose increment size or time step. It is on automatic by default, but you can choose fixed time step. I prefer this one, and as you can see here, your time step is not fixed. It is larger in initial times, and you can modify all your increment sizes depending on your problem and requirements. Okay, and here you can see all your steps that you have defined. You can edit, delete them, and you can create new ones. Okay, from here you can define your boundary conditions and your loads. And as you can see here, there are some options here that you can define your boundary conditions, such as velocity, displacement, or other ones. For example, if I choose this one, it wants me to select regions or points. I choose this node here, and if I, for example, select encapsulate boundary condition, I won't have any degrees of freedom at this point, but I prefer to choose this one. I choose a node, and I suppose we have only 1 degree of freedom, which is rotational. And again, for this node, I have 2 degrees of freedom. One of them is rotational. Yeah. And then I can apply the concentrated force from here. There are other options here, and here I want to apply the force at this node. Now I can define the vector of the concentrated force, which is presented in the global coordinate system. Here you can choose other coordinate systems if you want, but I prefer to define the vector in global coordinate system, and I enter the magnitude of the force in X and Y direction. Okay, and here you can see the concentrated force. Okay, we are done here, and can apply the mesh. Obviously we have a wire here, and after you choose a global size, as you can see here, you can change it and then apply it and check it out. I suppose number 3 is reasonable, yeah. And from here, assign element type. You can choose all elements to be assigned here, and from standard of element library we can easily find truss from here. The other options will not be modified, and then you must remember that you should apply the mesh to your part instance. So I click on yes here. Okay, then we can go furthermore, and here I create a job. When you are creating a job, you are creating a section for your simulation, and you can manage your jobs here, and you can submit different types of jobs you have defined previously. So I submit the job I have defined, and here you can see the job and other steps. For example, you can see your parts here, you can see your loads and boundary conditions, and you can edit them if you want. The job is running, and yeah, here you can see your results, and there is a very weird behavior here, and from this window here you can plot your results, and it depends on your requirements. For example, I want to plot displacement of a node. I click on ODB field output, and then I choose unique nodal, and here I can select magnitude of the displacement of any node. Okay, then I choose a node. For example, I choose this node from here, and okay, we can see the displacement and the magnitude of the displacement from here, and you can see the other components of the displacement vector. Thank you for attention. I hope that this video could help you in learning process of Abaqus CAE. Thank you.